to use. So if the vectors are not at right angles, the Pythagorean theorem does not apply, as we just mentioned before. Instead, you use the law of cosines or the law of sines. So for example, two vectors. If you recall how I put these two vectors together, if A is my first one, B is my second, I put the vectors together from tail to head, or head to tail. So for example, A, the head, and I put it head to tail. Okay, so the head of my A side is the arrow. I put it to the tail of my B side. Okay, let me go back so you can see how you put them together. Head to tail. And at that point, you can now have a resultant vector. This is my third line, which completes my triangle, and that's my R side. And now I'm completing my triangle. So you'll notice that the opposite angle to my R is my theta. The opposite angle to my A is my angle A, and the opposite angle to my B side is my angle B. And all of these angles are less than 90 degrees. And this is what a typical triangle with angles other than 90 degrees will look like. So let's work out an example so you see how this concept comes into play. So, so find the magnitude of the sum of a 15 kilometer displacement and a 25 kilometer displacement when the angle theta between them is 90 degrees and when the angle theta between them is 35 degrees. So I'm essentially working out two problems in one here. So I have a magnitude of 15 kilometers and then a magnitude of 25 kilometers. And I want to find the displacement of both of those when they are 90 degrees apart and 135 degrees apart. So here are my givens. I know that side angle A is 25 and B is 15 kilometers. And then I have two thetas that I'll be working with. So I'm solving for R. I'm solving for R for 90 degrees and R for 135 degrees. So here again, here is my side A, 25 kilometers. And side B, I've already put it together from head to tail. So I can see my two vectors, putting them together. And then when I add those two vectors together, I get a resultant vector, R. And this R is at 90 degrees. So these two vectors are at 90 degrees apart. And so because I have a 90 degree angle between these two, I can just use Pythagorean theorem. A squared plus B squared equals R squared, or C squared. So I can replace my A and my B with the magnitudes, which is 25 and 15. And of course, before I do that, I know that I'm going to end up square rooting both, so I can find R. Okay, so I replace my A and my B with the two magnitudes, 25 and 15. I do a little math, and I end up with 29 kilometers. So the resultant vector is 29 kilometers. So if I travel at 25 kilometers and then I take a right turn for 15 kilometers, I'm going to end up at 29 kilometers away from my point of origin, from where I started off. Okay, so that's half the problem. The other half is I want to know what the resultant vector would be for 135 degrees. So I still have the same root issue where I'm going 25 kilometers in one direction, but this time instead of turning at 90 degrees, I'm going to be turning at 135 degrees. So it's going to be slightly further away, as you can see there. So 135 degrees is slightly further away, and now I can write in my resultant vector. And now I'm going to use law of cosines. Because I have angles that are other than 90 degrees, okay, I use the law of cosine. So the law of cosine is r squared equals, because I'm looking for r now. Now there's three versions of the law of cosines. This is the version that I use if I'm looking for the resultant vector. So r squared equals a squared, so side A squared plus side B squared minus 2 times side A times side B times the cosine theta, which is 135. Alright, so now I'm replacing all of my A's and B's with the actual magnitudes of those sides, and I've also replaced theta with 135 degrees. So you might want to pause the video at this point just so you can see how I've replaced each variable with its value. and then I do my math, I end up with this. I have 625 plus 225 equals minus 750 times cosine of 135, and that simplifies to, so when I add 625 to 225, I get 850 minus a negative 530.33. So that essentially becomes a positive, and I add it all together, getting 1380.33. I square root both sides so I can get r by itself, and I'm going to end up with the square root of 1380 is 37.15. So the resultant vector for 135 degrees is 37.15. So you can see there that I ended up about 8 kilometers further away than when I did a 90-degree turn instead. So let me zoom in on this a little bit so you can see a little bit better. So in the red, you can see the resultant vector at 90 degrees is 29, and I have the dotted arrow there so you can see how that worked out. And then for the 135 degree turn, you see the resultant vector at 37.15. So you see the sum of both vectors. And that pretty much does it for that. So you can kind of see how law of cosines works. We'll be working out plenty of other examples in class. And that does it for vectors in 2 dimensions. Thanks for listening, and good luck with your studying.